5 problems to do yesterday. 5. And you guys probably didn't do it. Okay, let's do all of the things that let's do all the transformations even though you weren't supposed to, just to get you guys used to this. All right, number 1, what's my transformations? Left 1. What else? Down 3. Okay, anything else? Nope, that's it. Okay, what's the easiest way to do this? Calculator. There's 30 of them on the wall. Oh, you don't have one at home? Are you planning on going further in mathematics? No? Okay.
Yeah, exactly.
Here, you know what? Just hit the Y equals button. This button right there. See that button? Y equals? Okay. Just hit that button. And we're going to put in, this is the square root, correct? All right, so the square root, I'm going to hit the second key. And the x squared, see how that square root is up there? Symbol. And it puts it in there for me. Okay. And then I'm going to put in x plus 1. Now, because we're shifting this graph to the left one, you have to put the parenthesis in there. Make sure you close it off. And then we're going to go down 3. So minus 3. Graph it. Invalid. Take another calculator for now. Make sure I get that calculator. Kids play with it. How do I know what?
It's right next.
Oh, it's right here, below the mode button. See it? Okay. All right, so here's my graph. It shifted to the left one, down 3, my HK, my 0, 0, right? Let's get some good points so we can accurately graph this. The square root, so we're not going to have any, we're going to have some errors. Let's get some good points. I'd just like making a t-shirt. Let's see, -1, -3 is a good point. 0, -2. And 3, -1. That should be enough for the square root function. Let's try it. -1, -3. 0, -2. And 3, -1. So it starts here. And goes that way. What's our domain? This is square root function, so you're going to have to, it's going to be our, right, it's going to be our h, which is -1, includes -1, and it's going to go to positive infinity. Now, the negative infinity, positive infinity is for the cube root. Okay, both domain and range. What's our range? It's going to be our k, which is -3 and positive infinity. We good? Any questions? Huh? Can you hand me her calculator real quick? Number 2, what are my transformations? Not right 1, up 1, right 2. What about my A here? What's this going to do? It's doing 2 things. Going to flip it because it's negative. What else? Yeah, it's opposite the absolute value function. For the radical function, it's going to actually make it wider. Stretch it. Okay. Let's get some good points. Boy, that light is just right in the center of my screen, isn't it? Okay, -3 square root of x minus 2, close a parenthesis, plus 1. Graph it. See how it flipped it? Actually, somebody on the test put reflected, and I was impressed. All right, let's get some good points. So, second graph. Get past these errors. So it starts at 2, 1. The next one, 3, -2. Next one, 6, -5. Let's try it with these. 2, 1. 3, -2. 6, -5. Starts at 2, 1. Again, our h is 2 for the domain and range. Our h is 2. Our k is going to be 1. And it goes to, for the x, it goes to positive infinity. For the y, it's going to go negative infinity. In fact, we should actually put these, switch these, right? What? Oh, isn't it? No, it is positive. Sorry. You're right. So negative infinity to 1. Questions? Number 2. Number 3 we did in class, right? Number 4. What are my transformations in number 4? Any questions on number 2? For the x, you got to look at the x-axis. It's going to the right forever. Okay, so it's positive infinity for the x. For the range, it's going down forever. So it's going to be negative. And that's your smallest number. So you got to put that one first. Yeah, but I probably would just switch it on your quiz and not take off. Okay. All right. Any other questions? Congratulations. All right, number 4. What are my transformations here? What are my transformations? This is a cube root, so be careful. These are harder. The only thing that's different is what? Yeah, it has a fraction between 0 and 1. My A, it's positive, so it doesn't flip. So what does it do to my graph? Narrower, right? Compresses. What? Yes. If I used first hour video, yeah. Yeah. And then one time I had my switch on the camera wrong, and it actually recorded my email, the whole thing, the whole section, because I had my email up. And it's still on there somewhere. I got to find it. 2/3. 2 divided by 3. Does everybody remember how to put the cube root in there? Math, number 4, puts my cube root in there. We're putting x in, close parenthesis. The cube root. Okay, so I hit the math button. And number 4. Okay, it brings the cube root up in there. Okay, ready? A graph. These are, like I said, these are going to be a little tougher. We're going to need 5 points for this, for the cube root. All right, let's get to our table. And here's an outlier point that looks like. Ooh. Yeah, this really sucks. It is unfortunate. All right, so we're going to have to use fractions, right? So 0, 0, that's our HK, because my H is 0, my K is 0. So that's my HK. So we need one smaller. See, -1 and -2/3. -1, -2/3. That's what 0.66666. 2/3. And then I'm going to need another number, an outlier number. Let's see what we can use. Ooh. We have to go to -10. Let's try -10. And it looks like -1.4. Okay. Go the other way. 0, 0, 1, +2/3. And then we'll have to use 10 and +1.4. Double check, make sure nothing happened. Okay, you ready? Well, we're going to have to estimate. 0, 0. Okay, 1 and, so here's 1 and 2/3 is not quite 1. Then I have 10 and about 1.5. Okay. Same thing with the negative side. -1, -2/3. And then -10, negative about 1.5. It really squished this. It really compressed this. And what's my domain and range for cube roots? So that one's pretty tough. Let's do 5 and 6, and then we'll be done for the day. Number 5, my transformations. Let's see, I'm going to go left 1, up 3, and 2 is going to make it opposite, wide. It's the opposite from the absolute value functions we're doing. You know what? It's better to put it in a calculator and see if it's wider or narrower than to try to remember all that. Number 3 is wider because of A is greater than 1. A is greater than 1. So it's wider. A is greater than 1. So it's wider. Pardon me? Yes. Wider. Wider. Okay. All right. So like I said, if you instead of remembering all that, just put it in your calculator and see if it's stretched wider or squished. Okay. All right. Let's. As a matter of fact, let's put this in our calculator. I have 2 times the square root of x plus 1, parenthesis, plus 3. Good points. Let's see, second graph. This one I only need 3 points because it's a square root. 0, 5. Looks good. That's should be my starting point. Oh, no, it's not. Negative 1, 3 is my starting point. 0, 5, 3, 7. There's my 3 points. So negative 1, 3, 0, 5, and 3, 7. Do you see how it stretched it? Domain is going to be my h, which is negative 1. My k is 3. Let's see, this is going for the x value. It's going to positive infinity. For the y value, positive infinity. But that one was actually pretty easy. Questions, comments, concerns? And number 6. What are my transformations? Wider. Up 3. Left 1. There you go. Graph it. This is a cube root, so we're going to need 5 points. 2 times the cube root, math 4, x plus 1, parenthesis, plus 3. Graph. Second graph, we need 5 points. Here's my 3 real close points right there. My HK is negative 1, 3. And I've got negative 2, 1. Let's try and pick up an outlier point. Yep, -9, -1. Then the other way, I'm expecting 2, 1. Nope. 0, 5. And 7, 7. Okay, my HK was -1, 3. So -1, 3, 0, 5, and 7, 7. Bless you. -2, 1, and -9, -1. Here we go. It's a cube root, so what am I domain and range? Questions, comments, concerns? What's your homework thing? Yeah, what's the problems? Page 418, right? Numbers 22, 23. Nope, not 22. Number 7. Numbers 7, 11, 19, 25, 27, 28. You're supposed to accurately graph. I showed you how to accurately graph with the good points, right? Accurately graph. We want, you have to identify any transformations, which I did. Luckily, I did that for you. And what else? Domain and range. So here's your practice work. Yep, for today. Tomorrow when we do radical equations, it's going to do the rest of it. Questions, comments, concerns? Are we good? You probably could get this done before you leave today. Huh? Where? You need graph paper? All right, I'll go get some.